Hello, everyone. Thank you for joining this webinar. This is about testRigor and um, new features of testRigor and um, like how to scale your software testing with testRigor. All right, so let me start here and I'll share my screen. So first of all, what testRigor is about, it's functional end-to-end test automation tools. So what problems testRigor help to solve our customers? It is, well, first of all, speed of building test automation is extremely slow. Test maintenance is hugely time-consuming, and SDLC process is broken. It's absolutely backwards from how it should be. So first of all, let me point out that the speed with which you build automation sometimes matter. Sometimes if you are not moving fast enough, you might get in trouble, like we have seen many times. And I would like you to take a little bit of time to self-assess your test automation efforts. So it's very straightforward. You can calculate how much time did you spend building automation, which is number of people who were building automation times number of years we have been building it. So you get the time spent in many years. And then you can calculate the speed. So how many test cases does a person builds on average in your particular situation, which is very straightforward. The number of all test cases automated divided by time spent building these test cases in many years. So this, if you normalize it to give you average number of test cases built by one person within 1 year. All right. And if your speed is below 1200, then you're definitely in the red. Our customers build sometimes thousands of test cases in months. For example, one of the customers built 6,000, more than 6,000 tests in under 7 months with just 3 people. So next large challenge is test maintenance, and it is also hugely time consuming. So let me illustrate the point, and I'll make it a full screen. Imagine you are building a login test. This is an example of the test on the left. And the first time you build the test, it passes, everything is great. Then, of course, engineers would do some refactoring, add something, and the XPath for validation will break. Well, what does that mean, though? It means several things. So if your automated tests break, no one knows what is going on. Only QA automation engineers who build the test can actually go in and decipher what is happening. So it's engineering work and engineering hours to go in and basically see what failed, start the application, go through the steps, in this case, log in, and see did login actually work or not. In this case, yes, it most probably worked. So the problem is with the test itself, not the product under test. So you would, when QA automation engineer would need to literally go in and figure out a new XPath, copy that, put it into the code, save, promote to create a pull request, update it, and go for SDLC to update. As you can see, a little bit of a not a little bit, quite a huge overhead, reacting to a minute, maybe like minutes worth of work change from engineering. Next thing, of course, engineer would rename commit to sign in, because this is what makes sense. This is how it will work. Again, test will break, and again, it will introduce the overhead. And next time, again, we will fix the ID of the element, because look at it. The username ID format does not match password ID format. So we definitely need to be normalized, and engineers would most probably would do that as a part of the refactorings. What would it mean? Well, of course, when engineers would do that, they would make sure it works, but it will break the tests. Again, for no particular reason, introducing the overhead automation engineering to go through all of these hoops in order to be able to update the tests. Overall, so far, if you see here, these tests have been producing negative value. It ate engineering time and caught exactly 0 bugs. Moreover, since like you have to assess overall test suite that you have, does it overall produce any positive value, or it is just the negative overhead of it actually outweighs any positive value we can get from it. Compare that with manual tests or testRigor tests that would have been working all the time and all along, producing the value, helping engineers to validate that their changes actually function even though they do the refactoring. Why is this such a huge discrepancy? What's going on here? Well, it's very straightforward. When you write the test automation using traditional technologies like Selenium, Playwright, Cypress, and Appium, and so on and so forth, what you're actually doing, you're not actually testing the functionality. You're testing how engineers wrote the DOM structure yesterday. All your test relies on details of implementation. How exactly engineers wrote it yesterday, as opposed to how it should function purely from an user's perspective without looking into how it is coded in DOM. And of course, engineers constantly change the DOM. It is expected to change. Moreover, good end-to-end test should help you to validate if DOM changes without changing actual functionality actually function perfectly fine and not break something. So if you rely on details of implementation, instead it's exact opposite. So instead of helping engineers to validate that, hey, even though we did the refactoring, everything works, the tests break and introduce significant overhead on QA engineering instead. So this is definitely not what you want, and this is definitely the problem that testRigor solves for our customers. Example of that is IDT. They got stuck at around 33% of QA automation with our QA automation team, because at some point we just reached the saturation capacity. All of their QA automation engineers were full-time maintaining existing tests instead of building more automated tests and moving company forward. When we switched to testRigor, we quickly rebuilt to 91% in 9 months. Also, testRigor tests are in plain English, so we were able to add manual testing team to help out with building automation, and of course that helped. And this is the illustration of the problem here. So on average, with just regular websites, QA automation engineers would cap out at around 300, 350 end-to-end automated tests per person per year. In case of technologies like ServiceNow and Salesforce and such, that number is at around 30 test cases per person per year. This basically will make it a full-time job to just maintain the tests. And this is exactly what testRigor solves for our customers. It helps our customers to scale their QA automation efforts and help QA automation engineers to actually build automation instead of constantly sitting and updating existing tests. All right, let's move on and see what would be the problem with the process. So let's consider traditional SDLC process. And here, of course, I will simplify significantly just to illustrate the point. The traditional process, oversimplifying it, is product managers would write a specification, then engineers would write the code matching that specification provided by product managers. Then QA automation engineers would write QA automation code based on the code that engineers wrote to test what product managers had specified. Well, that is in theory. In practice, what happens is that QA automation attempt to write automated tests. What we find out sometimes that there is a mismatch between what product managers wrote and what how engineers understood it and coded it. And they, of course, escalate that. And more often than not, what happens is engineers have to change their code to adapt to the specification. Sometimes maybe product managers would need to clarify and update the specification to make it more specific, more clear, add more details. But point being is there is a redo. Engineers rewrite, change some parts of the code in order to match the updated specification. And then process repeats, find some bugs, engineers fix those issues, and process repeats. And if engineers were able to fit in the sprint, there's very unlikely that QA automation were able to fit in the same sprint as well. So basically, the QA automation here, we're playing catch-up game. It's like always losing game. Is almost impossible to catch up. But most importantly, if you're following this process, you are wasting your QA automation engineering resources on de facto manual testing as opposed to writing actual automation. So you hired experienced engineers who were supposed to write code, but instead they basically validating that stuff matches the specification. And this is it. This is probably not what you want to get from your engineering resources. Imagine that you can fix it. Imagine that you can write, your QA automation engineers can write QA automation based on the specification before engineers write the code. What would that mean? Well, it would mean that the hit of understanding this specification is now on QA automation engineers. They are the ones that find all of those discrepancies and communicating with product managers on clarifying that specification. Moreover, in testRigor, QA automation itself is in plain English, so product managers can directly review the QA automation that had been written. That's not possible at all in here. So nobody knows what QA automation engineers do there. So here, the QA automation write it in English, and therefore it's a shared understanding. It doesn't mean that you won't need to update this QA automation code after engineers wrote the final code. No, of course not. Of course, most probably the QA automation would need to be updated. It could be probably updated by engineers with some patches to the tests themselves, which can be stored in alongside with the code itself. But that's not the point. The value of this process is in clarifying the specification and adding additional executable specification for engineers before we write the code. And end result, based on the measurement with BNP Paribas, is 35% of engineering time reclaimed. You can get 35% of your engineering capacity back to you if you follow a better process. Moreover, you will get to significantly higher automation coverage because your QA automation engineers will be actually writing automation as opposed to doing manual testing. All right, that's good to know. How is it all done? This is plain English. testRigor functions on two levels. On a base level, testRigor parses and directly execute as an agent a subset of plain English, some direct commands like enter and click. And on top of it, there is a free-flowing English that is parsed using LLM. And then LLM basically will tells testRigor how to do specific actions in the language testRigor can understand and execute. Very straightforward. But since testRigor supports any free-flowing English, that also means that you can import your manual test cases from your manual test case management system for direct execution in testRigor. And the examples of supported and test case management systems are listed below. All right, you definitely not alone there. testRigor has the number of customers you might have heard of, such as Burger King, Cisco, and so on. All right, so on that, and testRigor have been picked up as a cool vendor by Gartner last year. So Gartner definitely loved the approach. So now let me show a small example to illustrate the point. Let's create a simple test suite. like e-commerce, and I'm going to generate any test cases right now, and we'll create the test suite. As you have seen, we have specified the landing URL. This is where all the test cases will be starting with. And let's create a very simple test in here. So test landing Kindle, and enter Kindle into search, enter, and check that page contains Kindle, and let's say not just Kindle, like Kindle Paperwhite. Some specific one, and we'll kick it off. There we go. It detected typo. All right. So how does that work? Remember when we created the test suite, we specified the landing URL. If you're talking about mobile applications, you would upload the mobile application. If you're talking about desktop, you could upload your desktop application or connect through RDP. And then testRigor will open the browser. Agent will open the URL, wait until it opens, and then will execute the steps. You can see it succeeded and found this Paperwhite on the left. Now, let's emulate significant change in eBay rendering. Of course, we do not have access to eBay production, but we will emulate that by changing the URL to bestbuy.com and restarting the test suite. And I'll open this test case in the new tab to illustrate the point. All right, so this is a new test, and I think it's going to fail. Oh no, because we just typed enter, it succeeded. We can rerun it again. So basically, once again, it is the same exact thing. Now the URL is different. So the URL which is being opened is bestbuy.com instead of ebay.com, but the steps themselves are identical. As you can see, it enters the Kindle into search bar in there, type center, and this is the highlighted Kindle Paperwhite on the left as a section there as well. So as you can see here, the exact same test ran on eBay, and now the same exact test runs on Best Buy. Moreover, you can compare, you always can compare a previous version. As you can see, it will show you a diff if there is any difference, but in this particular case, there is no difference. It's literally exactly the same test ran on both websites. What does that mean for you? That means that you can write test cases that test the functionality, because we validated that the same functionality works for both eBay and Best Buy. And you will not basically be investing into overhead of maintaining your test cases. That is the most important point in here. Okay, so now let me go ahead and show you the new features that are also extremely important. As we all progress, as engineers build more and more features, larger and larger part of those features are now using LLMs themselves to add value to your customers. So there are more and more LLM-based features that are being rolled out by companies because everybody wants to use AI to provide value to their customers. But how exactly do you test these features? And this is what we will be showing you, and this is what we will be demonstrating in here. So first of all, like we'll create a test suite for this website. And here it is a good example because another feature which is usually not tested are graphs and charts and diagrams. And you would want to automate their testing because sometimes those are extremely important part of your functionality. Let me create a test suite. We will, this is more online. Okay, word page. So we will create a test suite, and then I'll show you how to deal with this functionality in there. So basically, specifically, what we want to validate is that the balance is going down as a function and it reaches 0 at some point. And also we can validate, try to find any UI issues on the website. So, okay, so validate the graph page. And what we'll do is graph balance is always decreasing all the way to 0. I'll use F of that. And you can also go to documentation and check other validations in here. You can see what kind of validations were there. This is AI-based validations we were talking about. And we can also check for UI issues there as well. Let's kick it off. And while it works, let's talk about the next things, what we would like to do. And let's say we want to grab some value for, like, we can get either this text, which is rendered sideways, or largest amount of payments. Right? Let's say payments, and like we will be asking to get the largest payments on the graph. All right. So as you can see, it validated and everything is fine. Didn't find any issues. So next is we would like to get value description. What would be the description here? The largest value on payment scale. Scale using AI and save it as scale. So this is also sometimes important because sometimes it is very hard to figure out or rely on any particular way to address an element. And we are instead using AI to help it to extract the data for us, which will then we can use further in the test for validations of further steps of the test itself. Okay, let's see what happened in there. Okay, so it was 21/16 per month. Well, I guess this is like we formulated it incorrectly. So how about we will rephrase it and ask it to get the year of payout. Like, I'm not sure I can formulate it correctly. As you can see, it's very, very sensitive to how you formulate it. And clearly I did not do a good job in here. And this is what you would expect in general. You would need to find the clear, unambiguous formulation that will actually work. Okay, so here is the year of when the balance is paid off. And so it is in a year. So the result we would expect would be 2054. Well, it looks like it's not a text, so I can't select it actually. And this is exactly why you would want to use AI to get it for you. And let's see what it was. It was 54, as you would expect. And AI is always asked to provide the explanation of why did it choose specifically or what it have chosen. And that should help with identifying why it grabs something that you did not expect. You can read up and see, hey, like this is not what I would expect because so and so. All right. So this is all the new features for today. And I'm open for questions. You can type the questions to Q&A or you can type them in the chat if you'd like. Oh, perfect. Short and sweet. This is not the first time we talk about the topic. So there are apparently no questions. It's great. Let's. Okay, so where is the one question popped up? How do you catch an error? Like you do it exactly the same way as with any automation whatsoever. And I'll give you an example in here. Validate that page contains logo of Netflix. So for example, this is your the website and it's supposed to contain certain logo, but it doesn't in some cases. And basically the test will catch it and it's supposed to fail. Let's give it some time. So it will take a little bit of time because it will wait until the logo appears first, and only after it did not appear, then it will render a failure. And of course, you can control the timeout, how long AI will wait until element is there in the settings. All right, so there you go. It failed as you would expect. And you can basically expand that. You'll see RS info in here. And the statement is false because, and it will give you the description why this statement is false. So can testRigor generate test cases automatically? Next question is, yes, so you can help to build tests based on the feature description. So you can click on this button and let's say generate one test case and what you would want to generate in here. Like changing long-term, how about that? So validate that changing long-term would change the payments. User, I'm super simplifying because they probably will be significantly order of magnitude more specific than that. So this is a specification, an example specification, maybe not the best one, and you can generate a test case for that. And you can update it. And now AI will build the test case based on this description for you. The expectation is that AI will build anywhere between 30 and 80% of the tests the test for you. And there are techniques how to get it closer to 80% as opposed to by default would be probably closer to 30% of the test being built. But in any case, the idea is you'll get the value, but it is unlikely to just do everything for you. All right. Thank you very much for watching this video.